Okay, so we're going back to limits. Limits is the first chapter we did. And there were certain problems we just couldn't do at that point because we did not take derivatives yet. But now we're going to be able to do some of the problems we couldn't do before. And it's a good review of the stuff we did do before. So remember that the very first thing you try when you're doing a limit is just plug it in. So like this one right here, you can go 2 times 3 minus 5 divided by 3. And that's 1/3, and that's your answer. That's like what you want. See a ton of those. That's the goal. But then remember, like number 1, if I plug 2 in here, I'm going to end up with 0 over 0. So what do we do next? Factored. So then I could say this is the limit as x approaches 2 of x minus 5, x minus 2 divided by x minus 2, cancel, cancel. 2 minus 5, and my answer would be -3. Let me show you what L'Hopital would tell you how to do that. L'Hopital would say, I'm not going to learn to factor, I'm not going to learn to rationalize, I'm not going to worry about fractions. Because, like, there's teachers that actually don't teach limits in some things. Because you can do about half of what a problem with this. Not one of those teachers, but I see it. I can understand why it makes sense. The L'Hopital's rule would say, you have to first prove that you can use it. And you can use it if you plug in and you get 0 over 0 or infinity over infinity. So if I plug 2 in here, I'm going to get 0 over 0. So the person grading it, in this case me, but that's the grader, they want to see 0 over 0, and then they want to see that you know, oh, hey, that means I can use L'Hopital. So you just put like LH. Which should it be called? When I went to the conference, they told me LH. I'm sure LR is fine. So what he would say is, all right, this is not quotient. It's different. You'd say to find the limit, I got 0 over 0. So because I got 0 over 0, I'm allowed to take the derivative of the top, the derivative of the bottom, and try again. I'm not doing quotient, not the 2d1 minus 1d2, all that stuff. It's just what's the derivative of the top? 2x minus 7. What's the derivative of the bottom? 1. Can I plug into that? Yeah, so I can do that. So 2 times 2 minus 7, I got -3 a second ago, right? I still get -3, it's just different. So there are teachers that just never teach the factoring. They're just, screw it, what's the point? I don't think that's the best way, but. So let's look at a couple of the other ones. Well, because it makes it so easy, they can kind of make it a little harder too, So you have to like show why you're using the rule. So you have to say it's either 0 over 0 or infinity over infinity. And then you have to say, I'm going to use the rule and put LH. And then so if I plug into, obviously going to get 0 on the top. I'm going to take a shot in the dark and see if I get 0 on the bottom. It's 0. So whenever you have 0 over 0 or infinity over infinity, either one, now I can use L'Hopital. So I'm going to take the derivative of the top, which is 1. Derivative of the bottom, 9x squared minus 12x plus 1. Again, it's not quotient. It's a separate derivative. Derivative of the top by itself, derivative of the bottom by itself. And now I can plug in 2. I won't get 0 on the bottom. So it's 36 minus 24, so 1 over 13, that looks like. Questions there? Alright, next one. I plug 0 in here, I get sine of 0, so 0 degrees. What's the y value? It is 0. If I plug 0 to the bottom, I'm going to get 0. So because I get 0 over 0, I'll tell you I'm using L'Hopital's rule. And then I'm going to take the derivative of the top and the bottom. So the derivative of sine of 6x is cosine of 6x times 6, remember the chain rule piece, over, and then the derivative of x is 1. And now I'm able to plug in without getting stuck. So if I put 0 here, cosine of 0, so the x value at 0 degrees is 1, right? 1 times 6 is 6. And then 6 over 1, so it's just 6. Questions there? I know what that is. Yeah, because like people have been saying that. Like my son told me what it was. Well, I understand it now.
I understand it now, yeah.
Yeah. But I thought back and like 6 people said that exact phrase to me that day. But I was just like, oh cool, I'm awesome. Like I didn't know it was like a meme. Like, okay. So plug in 0 here. Cosine of 0. What's the x value of 0? 1, so 1 minus 1 is 0. So I have 0 over 0, so I'm going to use L'Hopital's. The derivative of 1 goes away, the derivative of negative cosine is sine. Yes, okay, good. I was wanting them to do that. I plug it up. Again, what am I going to get? Get 0 over 0. So you can do it again. You can do it again. Like, you could just keep going. So I get 0 over 0. So I'm going to do LH again. So what's the derivative of sine of x? Cosine of x. Derivative of 2x is 2. Now you go. And now it'll work. But if that didn't work, do it again. Like you can just keep going until it works. So cosine of 0 is 1. So as I was going through that, I was like, this is the same as 2 and 3. I'm glad I did it. You gotta realize you can do it. So the 5 is different only because it's not 0 over 0 when you plug it in out. What do you get when you plug it out? You get infinity over infinity. So it's still L'Hopital's rule. I just want you to realize it could be either 0 over 0 or infinity over infinity. And on the test, you have to show me that for whatever problems you think are L'Hopital's rule. And then let's do it. So the derivative of 2x squared is 4x. The derivative of e to the 2x is e to the 2x times 2. General piece there. I'm plugging in infinity now. Again, but I'm going to get it. Yeah, I'm just still stuck. So I'm going to get infinity over infinity again. I'm not giving up. I'm going to keep L'Hopital. The derivative of 4x is 4, and the derivative of 2e to the 2x is 2e to the 2x times 2. Well, we got 2 times 2 on the bottom and 4 on the top, so I can't move that. We got 1 over e to the 2x. If I plug infinity in for x, I get 1 over a gigantic number, which is good so far. 6 is not a new problem. It's just telling you, like, some people get confused with the quotient rule of L'Hopital's. It's just reminding you, if I ask you to take the derivative of a quotient, that is quotient rule. This is not a limit problem. You have to actually do 2d1 minus 1d2 over 2 squared. So it's just like pointing out the difference between them. So if I were to do this, second thing times the derivative of the first thing minus the first thing times the derivative of the second thing on the bottom, and that would be your answer. But again, it's just reviewing, like, hey, make sure you realize quotient rule. Asking to take the derivative is not the same as seem okay? Yes, no. Thank you. I understand. worry about